Hello, we're Team Umizoomy, and this is our final project. My name is Jessica Baza, and joining me are my other listed fellow peer members.
Hello.
Hi, I'm Kylie Rowe.
I'm Allie.
Hi, I'm Ruby.
I'm Alice.
All right, are you ready to dive in?
Yes.
Mm-hmm.
Mitchell, could you tell us about the measurement of size?
Yes. As you can see, what we're showing here is how big and small some things can really be, and how fast they're going, like our solar system here. Basically, we're not moving, the Earth is moving. And when it comes to like the size of the Earth, it's about like the size of a moon next to Jupiter, especially when you see like size on the side there. And if you can switch slides, please.
Oops.
Too far.
My computer was being silly.
Okay. So here is kind of how fast we're going right next to Jupiter. And the scientific notation makes it easier to write really large and really small numbers, depending on what the situation is.
All right.
I have my theory for it. I can't see. Ruby.
Isotopes and dividing numbers.
Amphitos, and can you explain amphitos and dividing numbers?
An isotope of a curve is a line such as the distance between the curve and the line approaches zero as they tend to go infinity. Like the curve will go as far as the numbers go, and the isotope won't ever like touch the bottom, but it will like skim it just a tiny bit. But even if the numbers keep going on, the curve will always keep going on because there's infinite amount of numbers, so it'll go infinite amount. And when you're dividing numbers, like you can divide numbers an infinite amount of times because the numbers never end. And when you take the prescription half-lives, you could take it and then it'd still be in your system for a good amount of time, because as the prescription gets more in your body, it keeps dividing and dividing. And
So
I think it stays in your system.
So what you're saying, every hour that goes by, the prescription in our body halves itself.
Yes.
Awesome. So on this slide, I'm explaining about theoretical probabilities, and theoretical is kind of like what we assume to happen, but we're not going to actually do an experiment for it to happen. So we know that when we conducted an experiment on rolling dice, we know that a dice typically has 6 sides, and when you roll it, you're going to get a number 1 through 6. So in these scenarios to the left here, we talked about doing the sum of 2 numbers, which would be adding die 1 and die 2, and then we did prime numbers, sum of 3, and multiplying together, I believe is that last one for yellow. And these in this chart to the right is our probabilities of those odds. So it's for the sum of 2 numbers would be there's 18 possibilities there's 18 chances that it's going to be I believe an even number out of 36. And then we used Excel to reduce a fraction, make it a decimal, and turn it into a percent. For empirical probability, we actually did perform an experiment by doing picking a random number between 1 and 6, and the computer just automatically picked numbers for us. And as you can see in these charts to the left, that represents our graphs to the left, that represents our charts to the right. The less roles we have, the more crazy and widespread the data is, and the more roles we have, the more tight and correlated the data is. And that's just different methods. It also ties into different methods of population samples and stuff that we learned later on. Allie, what is misleading and false data reports?
Misleading and false data reports are where companies or people will present data that may be true, but can be misleading to the eye. For example, right here we have the unemployment rate percentages, and it looks like the unemployment rate was much higher during the Clinton administration than it was in the Bush administration. So when we correct the chart and re-input the data, we can see that there's not much of a big difference at all. And it's the same over here with the player scores. It looks like there's a bigger gap in between each individual score than what there actually was. Why would someone want to present misleading data? For a number of reasons. For the presidential election, being able to show something like this without people actually doing the research themselves and just looking at it, it would be easy to assume that there was a lower percentage rate with the Bush administration. I really like this one when talking about misleading data. They say it's all about how you cut the pie and how you divide it up. So here on the arena funding on the original chart, it looks like the city gave right at half of the funding for the arena funding, when in actuality they gave a little over half, and then the other three maybe not quite divided equally, but as you can see over here, the AEG gave a very small percentage, and on the side it looks like there's more. I like to think about it. I have this image here with the carrots and the peas. Something I learned when I was little was that if you divide up your peas and push them around to the edges of the side of your plate, it looked like you ate all your peas. So it was leading to my parents. I may not have eaten even a single pea, but depending on how I rearranged them on my plate, it in fact looked like I'd ate a good portion. So it's kind of the same way with these charts. Depending on how you rearrange it on the plate, kind of shows what people see when they interpret the data. Oh, and then I added a third slide on this one, misleading and false data report. It just kind of gave some ideas of the different ways that people could create a misleading report. And so the first one, omitting the baseline. In most cases, the baseline for a graph is 0, but writers can skew how data is received by making the baseline a different number. And so you can see that here. Number 2, manipulating the y-axis. Expanding or compressing the scale on a graph can make changes in data seem more or less significant than they actually are. So here, the line is pretty equal, going across, it's not a wide range, but by changing that axis, it looks like there's more of a dramatic cut to it. Number 3, cherry picking data. Writers only include certain data points on their graphs to reinforce their narratives. This can create a false impression of the data. Number 4, using the wrong graph. The type of graph you use should depend on the type of data you want to visualize. Using the wrong type of graph can skew the data. Writers will sometimes use the wrong type of graph on purpose. So it's probably easy for a newbie, a beginner, to maybe use the wrong graph in presenting something, but someone who knows what they're doing may intentionally go in and use the wrong graph just to kind of give the wrong picture. And then number 5, I thought was interesting, and it was something I hadn't really thought about. Going against conventions. It says over time we have developed standards for how data is visualized. Flipping those conventions can make a graph confusing or misleading for readers. So on this one, on number 5, you can see a lot of times people will relate a darker color to like a higher number, a bigger number, and lighter colors to lower numbers or percentages. And so sometimes companies will flip the data or flip the colors or whatever, something that our mind has gotten used to considering to be the norm. They will just flip that. So they're still presenting true data, but our minds perceive it the other way around because we're so used to seeing lighter and darker colors referencing the opposite.
Interesting. I never thought about companies manipulating colors like that. But
Yeah, I hadn't thought about it either until I read that and did some more research. So,
well, thank you. Ruby, why do we need different sources to report different things?
Like, you need different sources because it could look differently. Like, in the table right here, you could see all these numbers, and then it may not look that different, like, on the numbers, but when you look at it on a chart or a graph, when you look at it on a graph, it may look a whole lot different than you think it would on the table. Because
So, what about, did you get 2 different sources for those? For the graph and chart?
yes. On one source, I got like different numbers than I got from the other source.
Okay.
And
I
it
can
was
see
like,
it better in this slide.
it was just
Which one's the FDA one?
the top one.
Okay.
I also think it's on the next slide too, but I'm not sure. And on the next slide, on correlation versus causation, on one side, it looks all random and you can't tell which one is which, and on causation side, it looks neater and you could tell the differences in the different amounts of it, even though they're like, I think they're off of the same thing, but I'm not sure.
Okay. So this one is about the probability of getting answers correct on a quiz. A student guessed on their quiz and they got 80% correct, and we had to use a Excel formula to display this. This also could work the same way for our lottery tickets. I used the combination Excel formula, and I also used it. You can see my different formulas on this slide for the lottery tickets, and just explains how if we buy a lottery ticket, we're automatically out $5, and our chances of winning, or our expected outcome, if we were to buy, like, let's say like 20 tickets, we would consistently lose at least $3 every time. So, and our seller would gain the opposite of that. So, I don't really know what else to say about probability.
Probability of obesity in America. So there are 206.1 million of Americans. About 10 million of those are obese. 0.3 million with type 2 diabetes, 23.3 with high blood pressure. There are about 27.7 million who have all three of those, obesity, type 2 diabetes, and high blood pressure. So the probability of an American being obese is 63.2%. That's a little over half of the population. And then obesity and high blood pressure, the combination of the two is about 16.1%. So 3.1 on obese, 7.2 on high blood pressure, 16.1 for obesity and high blood pressure, 0.9 for obesity and type 2 diabetes, and 8.5% for obesity, type 2 diabetes, and high blood pressure. Okay, obesity by location. This was an interesting one to look up, and I actually found a place where I could just put in, was able to look at the state and the year. And the first time I did these charts, I didn't realize that the years changed. And so I had one from like 2004 and then just different years. And so it didn't make any sense. The numbers weren't adding up. So I was able to get it lined up with 2017. And we can see that California has one of the lowest obesity rates at 25.1%. It has ranked number 48 of all the states. Missouri is at 32.5% and rated at 17. And then Arkansas is actually in the top 10 for obesity at 35%. I think California, there's a lot of activity that goes on there, a lot more walking, a lot of biking and things like that versus here. I can't really explain the difference between Missouri and Arkansas. There's not a huge difference, but enough to say that Arkansas has quite a bit higher obesity rate than most of the other states.
It's very interesting. Kylie, what do we know about Blood Now Calm? How can we compare it?
Okay, so first of all, you can see that the charts that I included here display the blood alcohol rates and the incidence and the level of urbanization in rural and the city town or the city life of the areas. Now, we can't really it cannot be projected to be different populations of the U.S. accurately because the difference in population, transportation, and size of the location make it inaccurate to be able to compare them to America. But you can see in the chart that there are substantially more accidents reported from rural roads than in the city. This may mean that people are more reckless because of less fear of getting caught. It also may mean that the individual using the rural road thinks that they can avoid getting caught while impaired. And here, this is a chart. This is the polydrug chart. It shows you the number of combinations of substances detected in the population after accidents. And, you know, of course, it shows here that 59.9% are negative for all substances, but there is 19.9% that have medications in their system, and 0.2% have everything included on this chart in their system.
That's crazy.
Alcohol, of course, you know, they have 9.7%.
I think texting should be on this. Texting should be an abused substance.
It can be if you're in a vehicle. It definitely it is a hazard to your health for sure. Prescription drugs are included, so I believe that if we excluded that information, the results would be much different. It's also possible that the prescriptions are being like not being abused, and they're just
Just in their
medicated.
system, period. Yeah.
Yes, that they're prescribed. So I find that interesting to think about. And that's
Okay, Alice, can you tell us about you approve? What do you approve of?
On this slide, we are looking at different parties, the Republican, the Independent, and the Democrat, to see who approved or disapproved of President Trump and his rating. So you can see in the left, I made my own chart or my own graph out of the individual cells on Excel. And we look at the percentage in the second graph. You can see the percentage of Republicans that approve is 87%. Those that disapprove is 12%, and that is your Republican Party. The graph at the bottom shows the percent of Democrats. The number of approval for Democrats is 8%. Those that disapprove is 90%. That is a huge percentage difference between the Republican and the Democratic groups. Over to the right is a pie graph that gives you the same information, but it's at a different glance. And you can see for the Republican Party that the pie graph has a very large green section as your approval ratings from the Republicans. And the bottom pie chart is your Democratic. The larger section in that one would be your 90%, which is your disapproval ratings for that. On this, we're going to look at U.S. military by gender, male or female. We're going to look at the different types of service, whether it be Army, Navy, Air Force, or Marines. Our percentage of women versus our percentage of men. In the Army, you can see we have 32%. In the Navy is 37%. In the Marines is 16%. In the Air Force is 40%. Versus your percentage of men, which is greater in the service. And that would be your 68%. In the Navy, 63%. In the Marines, 85%. In the Air Force, 60%. If you look at the bar graphs at the bottom, you can see, again, the percent of women versus the percent of men. The percent of men is your lighter greenish, and there are much more in either branch of service that you would choose. So if we look to see what the probability is of a man versus a woman being in the military, the greater chance you would find would be men in the military.
Thank you. This slide is about standard deviation. And what we used for this one was random mall shoppers and Army Heights. Over here to my left, you can see that I used my standard deviation formula, and it came up with the number for me, and it used the information based on my quartiles here. And you have 5 quartiles. You've got the first one, the median, the third one, and how you read these on a box and whisker plot is this line here in the center is your median, and to the left would be your quartile 1, which would be your low, and the value, the one to the right, would be your quartile 3, and that would be the high value. And the thickness is determined by about how much or tightly correlated each number is within each other. So in the Army, you can see that it's real tightly related to each other, which is giving it this really thin line. And then in the random shopper heights, it's got a thicker line because we have the data is like more all over the place. And coefficient variation is just the variation between the mean and the standard deviation. And this one is mostly just to show you how I came up with that using my Excel. Ruby, which age group are you?
I think you missed a slide.
Oh, sorry.
I'm sorry.
My computer keeps like over clicking, so I'm sorry.
Mine does that too. The probability of being distracted could depend on your age, or it could also depend on like social media or anything like that. Like, for instance, the group 16 through 24, they could be really popular with the Snapchat and the Instagram, and so they'd be texting distractedly, while versus 70 and older might not have that and could be not distracted. But it also says that older people, like 70 and up, it's random, so it just depends on the older person, I guess. But younger people have the more probability of being distracted while driving. And on the next slide that says, which age group am I? I'm in the more distracted group or age group.
Do you actually text and drive?
I do everything and drive. I ate watermelon while driving.
She's honest.
Safe out there.
I was hungry though, and the watermelon was good.
All right, so this one is about understanding bell graphs and where all the information is put. So bell graphs help us read percentiles, they help us read z-curves, probabilities, confidence intervals, and basically all of these are the same number, they're just represented in different ways. So on this one, it's easier to kind of explain, but this line here would be our percentile rank. This is where people fall into that category. And I chose to do, let's see, how do I want to explain this? We had to choose people to do our mass body index. And I chose to do Ryan Reynolds and my husband and myself. And basically, I just used our z-scores. I used my Excel, which to figure out this information. Also, on this slide, I'm sorry. We already talked about asymptotes. I also talked about that. So confidence intervals are a range of values so defined that there is a specific probability. So that would be the more accurate numbers. Do you remember how we had to use the standard deviation chart and divide a couple of numbers, and that's essentially how we got our score here, this z-score? Well, that's what I did. I used that and I recorded to make these lines. And I'm bad at this, so.
Who had the
Best BMI.
Best BMI? You, your husband, or
Ryan Reynolds, of course, because Deadpool can't save people if he's fat.
That's true.
right, distribution of American income. I just want to start with the U.S. map over here. It's a good example of what we were talking about earlier on the darker colors having a higher rate. And so Arkansas is actually one of the highest poverty-stricken states in the United States. You can see that represented by the darker colors there. And then the lighter colors, Montana, Arizona, over there. So some of the outliers that keep distribution for American income normal are going to be the poorest families, over here on the left, the poorest of the poor. And then over on the far right, we've got the top 5% of income or highest income earners. And so their income is quite a bit higher than, exceptionally higher than that of the poorest. And so it makes it very difficult to distribute income evenly or to get a normal graph line on American income.
It's very interesting.
Struggles with starting a business. Well, one of the first things with starting a business would be the capital. You've got to have capital to put into it, or startup money, assets, whatever it is you need to get your business going. And so you've got to find capital. That is the baseline. And once you have capital, once you've got the business going, it's likely that your investment is going to get greater. So your finances are going to drop. And that's represented with the darker pink dot down at the bottom. And that could be caused from investing in product, investing in services, unforeseen issues. Maybe you, what happened here?
I'm sorry, I don't know.
Maybe you.
Today's not my day. I'm so sorry, ladies. And
That's okay. Maybe you have a plumbing issue that you weren't counting on, so that you're having to invest in that, or your computer crashes, or some of your product wasn't good, whatever. That you're going to keep investing. Eventually, you will get to where you are maybe not necessarily making a profit, but you're earning some of your money back. And so it goes up and starts to go up like that until you get to the point to where you break even. Now, I feel like this chart isn't completely accurate, or that the assignment wasn't completely accurate. It would be great if we could hit that break even point and then our profits just kept going up. But realistically, it's probably more like a roller coaster where the profits goes up and down based on the economy, based on supply and demand, where you live at, the market that you're in, what your product or service is. And so ideally, our income would just go up from once we hit that break-even point. But realistically, it's probably not going to happen that way. And there's a lot of challenges that small business owners face. It's extremely important to support small businesses. I always try to eat local when I go somewhere. You are supporting the culture, you're supporting the neighborhood and the small business owners that big companies generally run out of town. So you're supporting those families in that community.
Mouse came out. So right now I have on the screen the wealth distribution in the U.S. I've got a couple of graphs here to show you the distribution. So interesting fact, by one measure, U.S. income inequality is the highest it's been since 1928. Wealth inequality is even greater than income inequality. NYU economist Edward Wolff has found that while the highest earning fifth of the U.S. families earn 59.1% of all income, the richest held 88.9% of all of the wealth. In 2016, yes, there we go. This is from 2018. So as you can see, the lighter green on the left-hand chart represents the U.S. holding, and the darker green is the household. While on the right chart, the household wealth is represented by the green, and U.S. wealth is by the blue. All right, next slide. And I made a pie graph. Uh-oh, you can't really see it. Is there any way to get the screen to be?
Whoops.
That's okay. Anyway, it shows here that the federal government spent $3.9 trillion, amounting in 21% of the nation's gross domestic product of that, and of that 3.9 trillion, over 3.3 trillion was financed by federal revenues. The remaining amount, 585 billion, was financed by borrowing. So in this pie graph, you see the distribution of our tax dollar and what it goes to pay for. The main thing that we pay for in our taxes is our Medicaid, I believe, which I don't mind at all. I really would pay more in taxes to make sure that everybody has the services that they need. So many people are so quick to down paying more in taxes for more services that provide for us as individuals, but not very many people understand that we're also not arguing about paying Shell Oil in our taxes every year and paying for Walmart Corporation to be open. So that's my spiel.
So this is more just kind of piling on to us already talking about taxes. These break down if you were to file head of household, single, and married filing jointly. So in these graphs, you can see that if you filed head of household, you get less left over than compared to if you're single or married filing jointly. Your taxes paid